Today, we're diving straight into the fascinating world of how AI actually gets work done. We're going to look at whether these systems are better off flying solo or teaming up to collaborate. Have you ever tried to do, well, literally everything yourself on a super busy day? Just imagine trying to take a serious work call, cooking up lunch, and helping someone with their homework, all at the exact same time. It's chaotic, right? Well, that is kind of exactly what a single agent AI system does. It acts as this one incredibly smart unit trying to juggle all the work. But let's be real, even the absolute best multitaskers have their limits. What if, instead, you had a dedicated chef, a specialized tutor, and a personal assistant, all working together seamlessly? That, my friends, is the true power of a multi-agent system. Here's exactly how we're going to unpack these two architectures today. We'll look at the solo act, the team approach, weigh the trade-offs, check out some real-world examples, and wrap up with a decision guide. Let's get into it. Section 1, the solo act, single agent systems. All right, let's start with the solo act. In a single agent architecture, you've got one autonomous entity handling all of the perception, reasoning, and decision-making entirely on its own. And honestly, because all that logic lives in just one place, these systems are highly predictable, they're way easier to build, and definitely simpler to debug when things go wrong. Think of it like a continuous loop. The agent gathers information from its environment, uses its internal logic to decide what to do, takes an action, and then updates its memory. It operates sequentially, so it has to finish one step completely before moving to the next, all while maintaining this neat, unified memory of the entire task. Section 2, the team approach, multi-agent systems. Okay, now imagine upgrading from that solo act to a highly coordinated dream team, a multi-agent system, or MAS. Instead of relying on one single brain to do literally everything, an MAS distributes responsibilities across multiple specialized AI agents. For example, one agent might be an absolute whiz at data analysis, while another is your go-to expert for user communication. What's really cool is how these specialized agents interact. They share data and collaborate to hit both their individual and collective goals. And because they're working together as a team, the system can actually process tasks in parallel, all at the same time, rather than waiting to do them sequentially. It's a huge speed boost. And sometimes, this teamwork leads to something truly mind-blowing called emergent behavior. These are complex, highly organized outcomes that just happen naturally. They aren't explicitly programmed into the system. It's very much like watching a flock of birds flying in perfect formation. It just organically comes together. Section 3, weighing trade-offs, comparing architectures. So the big question, how do these two setups actually compare? Well, single-agent systems are fantastic because they totally avoid the headache of complex communication protocols, which keeps your computing costs really low. But, and this is a big but, if the workload gets too heavy, that single agent can quickly become a bottleneck, and that leads to some frustrating latency and scaling issues. Now, multi-agent systems totally solve that bottleneck problem. They offer incredible scalability and fault tolerance. Literally, if one agent fails, another just steps right in to take over. But of course, there's a catch, and that's coordination overhead. Having multiple agents means you now have to manage how they talk to each other, and that definitely consumes a lot more computational resources and tokens. Interestingly enough, researchers are actually proposing a hybrid approach now. They're looking at cascading requests back and forth between single and multi-agent systems. It's kind of a genius way to try and get the absolute best of both worlds. Section 4, real-world examples, AI in the wild. All right, let's see what these systems look like out in the wild. A single-agent AI is really perfect for predictable, highly focused tasks. Think along the lines of a personal scheduling assistant, an FAQ chatbot on a website, or a banking system that flags fraudulent transactions based on strict preset thresholds. Multi-agent systems, on the flip side, are practically the brains behind modern smart cities. Take traffic management, for instance. You've got specialized agents monitoring vehicle flow, coordinating intersection lights, and even guiding drivers to open parking spots, just to reduce citywide congestion. It's a massive, coordinated effort. They're also completely revolutionizing global supply chains. You have different agents independently handling things like demand forecasting, inventory management, and logistics optimization, all running at the exact same time without stepping on each other's toes. Section 5, Decision Guide, Choosing Your AI Architecture. So, how do you actually choose the right architecture for your own project? It boils down to this. Choose a single agent if your problem domain is well-defined. You need a unified context, and your top priority is fast, low-cost delivery. It's perfect for those focused, linear tasks. But you should definitely choose a multi-agent system if your workflow is highly complex, involves a bunch of distinct roles, or crosses strict security and compliance boundaries where data absolutely has to be isolated. Ultimately, the experts suggest starting with a single agent prototype. Use it to test your assumptions first. Then only upgrade to a multi-agent team when your testing reveals limitations that your solo agent just can't handle. Start simple, then scale up. As we wrap up this explainer, I want you to consider your own bottlenecks and workloads. Think about the projects you're working on right now. Will your next AI deployment be a solo act, or are you going to need a highly coordinated dream team?